And so let me just kind of refresh your memory. The good part about being absent over the last few days is what I'm going to give you right now in the combined gas law is really all you need to know. All right, you don't actually have to know Boyle's law or Charles' law or any other individual gas law because they're all in here. Pressure, volume, and temperature are all in the combined gas law. If you turn that light off, I will show you what we've already seen and see if you can tell me what the combined gas law is. It's pretty darn simple. First of all, the combined gas law is going to relate all of these guys together. We had Boyle's law did volume and pressure, and volume and temperature was Charles' law. Well, if I put volume, temperature, and pressure all into one equation, that's the combined gas law. And I'll bet you can tell me what it is just by me refreshing you on what Boyle's law was and the other ones. Take a look.
Can we not take a look yet?
I'm waiting.
Okay. I'm running video today.
Always.
Hi.
Thanks.
How long will this take?
2 years. All right. Don't copy this down. You may remember that was the equation for Boyle's law. You may remember that was the equation for Charles' law. So there's Boyle's law, there's Charles' law. What do you think the combined gas law is? Raise your hand if you think you know. What do you think?
V2 P2 over T2
Equals?
V1 P1 over T1.
Exactly. See, you just put them all together. Isn't that nice? Look at that. There it is. V2 P2 over T2 equals V1 P1 over T1. Now, again, I can write that a bunch of different ways. I can write it all in one line. I can write it a lot of different ways. I chose to write it that way because most of the time when you're solving for these, you're solving for V2. So we kind of put V2 up in the top and to the left, so it's just a little bit easier to solve. Okay? You found that to be the case in the lab you did the other day when we were collecting gases in the syringe. Okay, that's it. Now, let me do 2 examples for you on these. There's a couple of things that pop up here that you're going to want to be careful of that didn't show their heads before. I'll also remind you of the stuff we were getting wrong from before. Okay, copy this guy down, and as you're copying it, you're going to see something. Well, a couple of things you're going to notice. First of all, it has every variable in it, so there's a better chance of you making a mistake, picking out the wrong guy, maybe even V1 versus V2 or T1 versus T2. So that's a possibility. Secondly, there's a new thing. I put it in red over here, STP. What the heck does that mean? All right. And there's a third thing you're going to notice at the end of this problem that actually makes this one have a lot of mistakes in it for a very simple reason, just simple math. Actually, it's not even math. You will have it set up right. You just won't plug it into your calculator correctly. It's not going to be a lot of points, but I'm going to try to get you to avoid doing that. Okay? So there are a few new things to show. Now, of course, along with those new things, there's the old things. You still have to pick out the information correctly, convert all the conversions we've been doing, rearrange the equation algebraically, and yeah, that could be a little bit harder for this one because it's got 6 variables instead of 4. But for the most part, there's the old stuff and the new, and we'll point it out as we go along. So let's start with the first step. We're going to pick out the given information and write it all down to the side. There it is. Okay? Now you do have to be careful. Let's read. Make sure you are going to say the same thing I was going to say. Okay? When I go to ask you for these things. You read that. Do you all see what I see for V1? Think. Everybody get in their head what they think V1 is. Yeah. All right? What do you think V1 probably is here, Ellie? 400 milliliters. It says a sample of gas has a volume at this. Has a volume of this at that temperature pressure. Calculate a new volume. All right, good. We know it's not the new volume because that's what we're being asked for. It is 400 milliliters. The new volume being the unknown. Good. P1 versus P2. Let's take a look up there. Read again. Which one do you think is P1? What do you think here is P1? Nikki, what's my initial pressure? 550 torr. Good. P2. What do we think P2 is? And then everybody get an answer for this one in their head because I will see some mistakes on this one. I got them last period. What do you think P2 is in this case? I'll be surprised if everybody knows this one. Jared, what do you think?
Is it STP?
What does that mean, STP? He's right. It is STP. Some people, in last class, they said P2 is the unknown. Can I have P2 as the unknown and V2? I have two unknowns in the same one equation? No. Or I can't solve it. P2 is something to do with STP. What is STP? You might want to write this down next to it right now. STP means standard temperature and pressure. Okay?
Oh, what now?
That's what it means. Now, given that, that's standard temperature and pressure. Okay? What is standard pressure? Do you remember? It's the number you had to memorize.
764.
760 torr. Good. I mean, it's also, by the way, it's also 1 atmosphere. But I would, since my other guy's in torr, I will put this guy in torr. Or millimeters of mercury, same thing. Good. What's my T1? Look at T1 here.
550. No, 10
No.
degrees. 10 degrees Celsius.
10 degrees Celsius.
I don't know what I was on there. Maybe it's hot and stuff.
All right, 10 degrees Celsius. Can I use that? No, I'm going to have to do what with it? Add 273 and get 283 Kelvin. And what's my T2? What's my T2? Again, it doesn't seem to be another temperature up there, but that's where STP stands for. ST, some people think ST, standard P, pressure. So standard pressure. No, STP says standard temperature and pressure. So T
273.
is 273. There you have it,
Kelvin.
which is nice. Okay, I've picked out the information correctly. I've even learned what STP stands for, so that's a little bit new. Now it's time to write the equation down. V2 P2 over T2 equals V1 P1 over T1. All right, now this one is not that hard to rearrange, but there, of course, are some more variables in it. Who can raise their hand and tell me what I'm going to multiply both sides by in order to get V2 by himself? What do you think? V2 by himself, what will I do to both sides here? Josh. Not now.
I don't know.
What?
I don't know.
Yes, you do. You aren't listening.
Divide or no.
What am I going to do to get V2 by himself?
2t.
What?
Multiply by 2t and do something with
Not 2T. I've never said 2T.
t2.
T2 and what else? How do I get rid of the P2?
Divide by t2.
Correct. All right, so everybody agree that's what you do to both sides? If I do that to that side, I do it to this side. All right. T2 cancels, P2 cancels, leaves me with V2 equals V1 P1 T2 over T1 P2. All right. Now, next step is to plug everything in. Let's do that. V1 is 400 milliliters. Keep your units. P1 is 550 torr. And T2 is 273 Kelvin. Over T1, which is 283 Kelvin. And P2, which is 760 torr. Now, I told you there was a last thing about these that's more difficult, that many people make this mistake, and I was going to try to fix it for you. Let me just, without telling it to you, let me see if you make it. Plug all that into your calculator and see what happens for your answer. Hurry up. I need everybody to do this because otherwise I won't know if you did it. Some of you, I can tell by your faces, know what I'm talking about. Others have no idea. Let's see. Let's see what we get for an answer. Everybody has to do it. Don't yell out an answer. Let everybody get an answer first.
Whoa.
I heard a whoa. That could be a person who got a bad answer.
Yeah.
I don't know. Let's see. Emily, what'd you get?
1.12918.
Sounds like Emily did exactly what I thought she would. Not she, but someone would do.
No, you meant me.
I did not. But I believe it now. I do mean it now.
Yeah,
Yeah, if you get some number like 1 million or 150,000 or something like that, no. Something went terribly, terribly wrong with your calculations. Who got a different, what it would think is a normal number? What'd you get, Mark?
279.
Anybody else get 279? Okay. Yeah.
Really?
Okay. If it's 279, before I show you what mistakes she made and what you might make if you're not careful, let's just remember one thing. I kept those units to double check stuff. Torr cancels with torr, Kelvin cancels with Kelvin, leaves me with milliliters. That's exactly what I would expect, and that's the right answer. Now, let's see what she did wrong. It's order of operations. Now, it's not set up wrong, but your calculator doesn't know any better. If you go this times this times this, divided by that times that, you may know what you're trying to say, but your calculator has no idea. It thinks this number is on the top. Okay? What do you have to do to plug this in correctly? There's actually a couple of different ways you could do this to plug it in correctly.
400 times 550 times 273, and then divided by that.
Well, that's exactly what you did and got the wrong answer. You're not answering the question. What do you think, Marvin?
You multiply them all across and use parentheses.
You could use parentheses on your calculator, and that would work. So this times this times this, divided by parentheses, that times that, close parentheses equals. That would work. All right. There's also a couple of other ways I could do it. You know what else I could do? Because they're both multiplication and division, I could do them in any order. So watch. This divided by that, divided by that, times that works. Because as long as the guys on the bottom are being divided, we're dividing by them, and we're multiplying by the guys at the top, it will give you the exact same answer. So I can go this times this times this, divided by that, that'll work. What you cannot do is this times this times this, divided by that times that. Because even though it looks like that's what's happening, you'd have to put parentheses around it first in order to do that. Okay?
Okay. So the scientific figures is 3 because there are.
Significant figures is 3 because he has 3, 400 with a decimal point. He has 3, 550 with a decimal point. He has 3, and you're saying, well, this guy only has 2. No. Why?
Decimal.
No. There's no decimal in this one, but he is our standard. Standards have an infinite number of significant figures. They're considered to be, like a counting number. They're like a perfect number. All right. If it was a number I say, hey, the pressure is 760 in the room right now, then I'd have to tell you how many decimal places. But if I say we're using standard pressure, then we're assuming it's exactly 760. So that does not limit me. Okay. All right. Good enough? All right, let's just do one more where I'm going to throw in one last curveball at you. Okay, watch this guy. Copy this one down. This is not a big curveball. It's just doing some algebra, a little bit harder algebra is about it. Because we're solving for a variable that's on the bottom this time. First things first, let's write all these down and see if you pick out the right things. Okay? P1, P2, P1, P2, T1, T2. See if you pick all of them out right. And I'll do them on the board. We still have one more lab, believe it or not, in this chapter. My original plan before all the snow days, we were going to have the test by the end of the week, but we have 2 labs to get in. I had 1 in the air class. 1 more lab to get in the review, and another day of notes. So it doesn't look like that's going to happen, especially since we're probably not going to have a full day tomorrow.
We're not going to have any day tomorrow.
Probably not, but I'm just saying. Okay, did y'all pick out these for your volumes and everything?
Yeah. Can they hear me on camera right now?
I hope not. What do you have for your initial pressure?
Two ATMs.
It's not ATMs. They're not automatic teller machines. Atmospheres. P2 would be,
They're correlated to Kelvin.
and temperature 1 is, and temperature 2 is 25.
298 Kelvin.
Plus 273 equals 298 Kelvin. All right. All right, we have another conversion to make besides the Celsius, which I always convert, even if both of them have been in Celsius. If I'm doing a calculation and there's the time when I have both of them in Celsius, I got to convert it. You saw that yesterday in lab. All right, same thing here. I've got to convert. Well, here it doesn't matter which way I go for this guy. I can convert torr to atmospheres, atmospheres to torr. What do you recommend doing? Doesn't matter. Torr on the bottom, atmospheres on top. 1 atmosphere contains 760 torr. What do you get?
1.12 atmospheres.
1 point. It should be 3 significant figures. 3, 3. So what would you 1 point?
1.12.
Oh, 1.12. I thought you said 1. Oh, okay, 1.12. Okay. Didn't hear the 12 atmospheres. Okay, good. All right. Now I write my equation out, and here's where I'm going to, my only real change in this one versus the previous problem, had a little bit different conversions. V2, P2 over T2 equals V1, P1 over T1. Now here's my problem here. I can try to rearrange by the basic rules of algebra for T2, but I showed you a couple of tricks. Last time I said you could flip them. Well, this time I'm going to, and I did that on one of the problems I was doing. This time I'm going to show you what will make most sense here is to just cross multiply. And figuring on the guy I want to solve for, keeping him on the left side already. Watch, let me show you. See, I'm looking for him, right? So I'm going to cross multiply and do it this way. T1 V2 P2 equals T2 V1 P1. That helps me because now the variable I'm looking for is set up on the left side in the numerator. And I know what to do to get rid of the stuff that's by him. What will I do to both sides to get rid of the stuff that's by him?
Divide by the V2, P2.
Exactly. And there you have it. You get T1 equals T2 V1 P1 over V2 P2. And the last thing I'll do is plug those numbers in. T1 equals, my T2 is 298 Kelvin. My V1 is 14.5 liters. My P1 is 2.0 atmospheres. My V2 is 12.1 liters. God bless you. And my P2 is 1.12 atmospheres. Now let me explain for you one last time why I keep my units. If y'all will just bear with me here. It's very possible at this stage, most of you who are smarter than me and are convinced you are, just either don't show me this, you like to not show it at all in the homework, or if you do at least, almost no one keeps the units in it. Because you're too smart. I mean, you will never make that mistake. But here's the obvious thing that would be picked out if you did keep the units. It's very easy. Someone will do it. Even a very smart person will be looking down here when they're looking for V2, what's P2, and you'll just look, okay, I need P2, it's 850. And you'll accidentally write 850 even though you made the conversion. I'd pick that up because that 850 would be in torr. And when I went to try to cancel atmospheres and atmospheres, it wouldn't cancel. So I'd pick it up. Oh, better go back and change that. You don't pick it up if you don't put the units. Okay? If you do, everything cancels out nicely, and you're left with Kelvin. What does T1 come out to be? Anybody?
638.
638 Kelvin? Everybody agree with that? Sound good?
No.
No? Why not?
I got 197.
Well, who's right? Who got 638?
Well, I know I'm wrong. But
Okay. Now, this is a good example of another thing I want to point out to you. Something that happened in the last class. What will Emily and the person who did this last class do at this point? She will take those numbers she just plugged in, and she will plug them in again. And then she will say, it's my calculator. And my calculator is wrong. It's doing it wrong. I'm plugging in the same numbers, and I'm getting the same answer, which the answer is wrong. Does that make any sense? What should she do? She should plug these numbers in. she should look up here and see which of these 3 numbers is wrong, or these 5 numbers is wrong. All right? Because I get people all the time who do this. Well, I did it 15 times, and it still comes out wrong. That's the definition of insanity. What's the definition of insanity? Doing the same thing over and over again and expecting a different result. That's the definition. You know, it's not really a textbook there, but it's a classic definition of insanity. So, if Emily got that wrong, and in your class several people got it wrong, they did something wrong besides plug the numbers in.
I read the 1 and 4.
There you go. So, what'd you do?
I have 4.5 liters.
And so she just copied a number down wrong. All right? So that, and now I kind of know because the number wasn't that far off, like her last one, she didn't do the order of operations wrong on the calculator. Because that will give you a number like, 1 million or something like that, right? I knew it wasn't that. I was probably just copying a number off the board wrong, which happens all the time. All right, good enough. Now your homework.